It's about time I made a little video reviewing Anthony Abruzzo's insights as well. He contacted me when he found out my own theory development was on the right track, and I believe his is on the right track as well, philosophically speaking. The details, though, I am flushing out bit by bit, and as it turns out, there's a lot more that astronomers and astrophysicists have ignored than what meets the eye. As well as geologists, you can't turn your back on this either. Don't hide, I can see you. And chemists, you guys seriously screwed up. I'll get to you guys later. But here's the conclusion concerning Anthony Abruzzo's insights. I'll go ahead and read this out to you because this is one hell of a philosopher, and I think everybody needs to pay attention to what this gentleman has said. I will link this paper to the bottom of this page, or to this video. But yeah, today is July 31st, 2015. Conclusion. Now, this paper is called, "Are Planets the End Products Rather than the Byproducts of Stellar Evolution?" He wrote this back in 2008 after he says over many years of research. Conclusion. The claim has been made that planets should be viewed as the end products and not the byproducts of stellar evolution. The overlapping gradations in mass between the heaviest and lightest spherical objects presented above for heuristic purposes, and without any consideration to individual variations, suggest just such an evolutionary continuum. It means bigger to smaller. There's no stepped discrete particle thing. It's a smooth transition from the biggest to the smallest. It was pointed out that the germ of the transformation hypothesis, I call it a stellar metamorphosis, traces its lineage to the Descartes vortex cosmology, and for reasons that were briefly touched upon, it was superseded by Newtonian physics and consigned to the dustbin of history. However, in reviving the idea, I have endeavored to show that in some not insignificant aspects, it is consistent with contemporary stellar evolution theory if the time restriction imposed by the Big Bang hypothesis is abrogated, meaning we throw it in the trash. In a universe of indeterminate age, where stellar objects lose mass from nucleosynthesis, solar wind, red giant phase envelope shredding, and finally proton decay, the focus of stellar evolution shifts from exotic objects like neutron stars, magnetars, I'm unsure if we should toss those, proton stars, quark stars, black holes, to mundane objects like brown dwarf stars, gas giant planets, rocky planets, and dwarf planets. This is so because the supposed density levels predicted for the aforementioned exotic objects turn out to be spurious, since the depletion of an object's mass and the contraction of its radius occur simultaneously. I made that conclusion as well. If we take the known densities of the non-stellar objects in our solar system as preliminary evidence, thus the need to wrestle with tortured description of hyperdense matter is no longer necessary, but we do have to study pulsars and magnetars in their correct perspective. Rather than look at them as dense, maybe we should use different ways of looking at the world around us. I'll go into that later. But basically, that's the whole theory in a nutshell, and the main point of the talk. Now, he says here, although mass depletion, the central issue facing the transformation hypothesis, I call it stellar metamorphosis, has been discussed within the context of standard stellar theory and the speculative concept of proton decay, there may very well be other mass-depleting mechanisms at work that are still unknown. Although the disintegration and constitution of fundamental matter is conceptually consistent with both the Big Bang and steady-state hypothesis, nevertheless it is not without the realm of possibility that mass depletion may obtain from an electromagnetic phenomenon of which we have very scant knowledge. But basically, the mass depletion he's looking for is mass depletion via solar wind, coronal mass ejections, and solar flares. There's your mass depletion. You have a billion years of that happening. I guarantee you the star is going to shrink considerably. As well, red dwarf stars lose mass in very large amounts faster than their larger pre-evolution counterparts such as the sun, because their flares are a lot more powerful. It's because they're forming cores in their center. I'll go over more on that later. But basically, what I wanted to point people out to is that Anthony Abruzzo also understands that we need to discard Big Bang Theory as being, nonsense, and we need to look at the universe as being an eternal construct that had no beginning or end. The universe as a whole. Now, I'm not saying galaxies are eternal. I'm not saying stars are eternal. I'm saying that objects inside of the universe live and die, and are born, live, and die just like any other thing, but that their time frames for doing so extend beyond the frames allowed by the Big Bang Theory. So basically, the Big Bang Theory has itself set up as the hard place, and the rock as theorizers who refuse to change and to pay attention to modern discoveries and modern insights. They still keep 17th and 18th century insights, which are obsolete. But which is weird, because some 17th and 18th century insights, as it says here, Descartes' understanding of the vortexes, I'm not too sure about that, but still, we need to expand our understanding of the universe by discarding theories that are just getting in the way. I already went over what today was, but yeah, like I said, Abruzzo, he knows what he's talking about. Now, a lot of these papers he goes over, I've read, he still talks about fusion, and I think we can discard the fusion thing, because clearly the nuclear processes that happen in the universe, stars are not powerful enough to be able to sustain those types of reactions. The objects powerful enough to sustain nuclear reactions are objects related to the birth of galaxies, and objects such as pulsars, where they emit giant jets of matter at almost luminal velocities, not superluminal, but luminal velocities. That's where the velocities required for fusion reactions to take place are located. Not inside the interiors of stars. The interior stars are just dull ionized matter, and it's actually, I think, cold, to be honest with you. I don't think stars have anything happening in them very interesting. I think if you sent a probe in there, you'd find out that the interior is quite boring. But anyways, there you go. Have a look at that paper, everybody. Later.